students, welcome to Decode NCERT series, and in today's class we are going to do the chapter Chemical Kinetics. Okay, so as I told you in every video what is the purpose, so I am not going to teach you this chapter here, but yes, I will be seeing throughout the NCERT book, I will be scanning, I will be telling you which are the most important topics where you should focus on. So you do not have to go and read the NCERT line by line, word by word, you just need to focus all those points which I will be telling you in this particular class. Okay, so this will help you to save your time and to use your time most effective way. Okay, so what you have to do now is to sit with your NCERT book, and you have to sit with a highlighter, a blue or a black pen to underline, and a pencil to write down the questions on the book. Okay, so please get these things and then sit with the class, and please follow the whole class so that you can mark each and every important thing. Okay, so now first let's get started here. So chemical kinetics, first of all, here something is there regarding what is chemical kinetics, like which branch it is, what it deals with. Okay, that is regarding chemical kinetics here. So highlight this part. Okay, next we will go to this part, that on what factor the reactions depend. So note down the factors here: concentration, temperature, pressure, catalyst affect the rate of a reaction. Okay, so these are the four factors. It can be asked as a question, it can be as an MCQ, like which of this is not a factor, which of these are factors. So any questions like this can be asked, so mark this. Okay, next if we go forward, so here you can skip everything, do not worry. Okay, yes, here you have to be little careful about the differential rate of disappearance of a reaction. So how do we represent the rate of a reaction? Either it is minus dr by dt, or it can also be expressed in terms of product. Okay, so that is plus dp by dt. Okay, now coming here we have something about average rate. What is the definition of average rate? So highlight this part, this can be asked. Okay, next we have the units of the rate of the reaction. So this is also very important. So one second, let me underline this one. So units of the rate of the reaction. Okay, so please highlight this one, this also is a very important question. Next if we go forward, okay, here only one more thing is there. So if the gases are in pressure, so the what I can say, the rate of the reaction will be in terms of atm per second. Okay, now let's move forward here, and I want to tell you that you should solve all the in-text questions. Okay, so please solve these questions and all, and if you want my help in this, you can just comment down that we need your help, ma'am, you can solve the questions. So very soon, once we complete this Decode NCERT, we will start another series where we will be doing the question answers. Okay, fine. Now coming to the next one here, that is average rate and instantaneous rate. So what is instantaneous rate and its definition, that is there. So you have to highlight this one and remember this one. After that we have this one, there's nothing to read here. Okay, these are all examples, you just can skip here. Okay, next we will go how to write the differential rate equation. Okay, this is important. So suppose this is the reaction, right? 2HI gives H2 and I2. So how do we write? So rate of the reaction is equal to minus half of HI by dt plus H2 by dt plus I2 by dt. Okay, so this is the expression for rate of the reaction. Similarly, you can just practice this as an example. Okay, so this is an example, you can just practice this one, this is important. Now if we move forward, next we have the factors affecting the rate of a reaction. We have already seen that, but again here we have concentration of the reactants, temperature and catalyst. These are the main important factors. Now coming to what is the definition of a rate law, you can see here. So definition of a rate law is very important, so you can understand and remember this expression. Okay, next coming forward to the next part, that is what is rate constant. Okay, so the definition of rate constant, K is a proportionality constant called as rate constant. So this definition is not needed, but yes, you should be knowing what is rate constant. And next we have the thing, what is rate law. Okay, again the rate law is defined in a very good better way here, so you can remember this definition for rate law. Okay, fine. After that we will come to something, I'll go to the next one. that is something order of a reaction. Okay, so here one very important thing, the rate equation derived is from the experimental data. Okay, the question can be asked whether it is theoretical, experimental, both theoretical, experimental. So always remember that the rate equation or the rate expression is always derived experimentally. Okay, now you can see here, this is important. Rate law for any reaction cannot be predicted by merely looking at the balanced chemical reaction, that is theoretically, but must be determined experimentally. Okay, fine. Now we will go to something called as order of the reaction, definition of order of the reaction. This is there. Okay, next, this is important again here. Okay, order of the reaction can be 0, 1, 2, 3 and even a fraction. Okay, a zero order reaction is also possible. Okay, so mark this one. Fine. Now if we move forward, here we have something called as what is elementary reaction and complex reactions. Okay, these two definitions you should be knowing. Okay, so mark, highlight this part. Fine. Now if I move forward here, units of rate constant, this is very important, how to find the unit of rate constant. Okay, so let me highlight this one. This is the formula to calculate the unit of rate constant, important one, so please mark this one. Okay, next we have, if you just go forward, this table, I can't tell you how important is this table. Okay, very important. You can see 0th order reaction unit is given, 1st order unit is given, 2nd order unit is given. So I think this may not be visible if I've zoomed it. Can you see this one now? Okay, so okay, one second, just a minute students, let me erase this one. What happened? Okay, one second students. Okay, fine. So this is there. Okay, now if I go to the next part, after this what I'll get is, just a minute, let me just adjust this one. Okay, fine. Yeah, we got it. Now if I just go higher now, okay. Now if you see what is molecularity of a reaction, so just now we discussed elementary reaction, complex reaction, next is molecularity of a reaction. So whichever I have highlighted in green, okay, that is for example. So unimolecular reaction, what do you mean by unimolecular reaction and the example of that, okay, and you also have the reaction for that one. Bimolecular reaction, example, the in terms of words and in terms of reactions. Okay, next here we also have here trimolecular or tetramolecular reactions. Here also this is important, so please highlight this one. I have skipped it. Trimolecular reactions involving simultaneous collision between 3 reacting species, and this is the example here. Okay, now coming to this can be asked as a question. Okay, why that why the reactions with molecularity 3 are very rare and slow to proceed. Okay, so let me just zoom it. Okay, I think you can see now. Okay, this is the statement and from here the question can be asked. Okay, so make sure that you mark this and understand this one. Fine. Next if we move is towards which is called as the rate determining step, which is rate determining step. This is important, you should know the definition here. Okay, after that just moving forward, you can find the difference between order and molecularity. Okay, 3 points are given, so my recommendation is read this and make a table and read this one. Okay, so what you have to do after reading these points, okay, make a table for this one, make a table for the difference between order and molecularity and write down so that you can revise it better. Okay, fine. Next you can see 3 points of difference are there. Okay, next if we have let me go to the center. Okay, next if I see integrated rate equation. Okay, one second students. Yeah, so if we have now integrated rate equation, right, so in integrated rate equation what you can do is you have to remember the formulas for 0th order. Yes, definitely this derivation is important, but derivation is something which everyone knows, right, like everyone knows means everyone knows that it will be asked in the exam, so you have to definitely prepare the derivation. This is also very important. Every year we get a question on derivation either of 1st order or 0th order, right, so this definition you must prepare, very important. Okay, next we have here next we have this graph for 0th order reaction. This is also very important. Okay, whenever you derive, it is important if you can draw the graph. Clear? Now coming to next one, examples of zeroth order reaction. This is super important. Examples of zeroth order reaction is given here. So please note down these examples in points and remember. Okay, question can be like a reaction is given to you and then it is asked you like which order reaction is there. Okay, and this is especially very important because here it tells you why it is a zeroth order reaction. Okay, so you can see some catalyzed reactions and reactions which occur on metal surfaces are few examples of zero order reaction. The decomposition of gaseous ammonia on a hot platinum surface is a zero order reaction at high pressure. Explain why. Why is this reaction a zeroth order? So explanation is also given in the book. You can see here. This part is the explanation, this part. Okay, so I can write like this part. Okay, underline this one. This is very important. On the surface of the catalyst, making the rate independent on the concentration. Okay, so one example is this one. This is example number 1 and this is example number 2. So this question can be asked why this particular reaction is zeroth order reaction. So you have to give the explanation here. Okay, so this is what explain. If the question asks like this statement is there and then explain is given to you, then you have to write this as an answer. Clear? Fine. Now moving forward. Okay, one second. Yeah. Now if I move forward here, first order reaction. So definitely this, what I'll say, derivation is important. Okay, very important. Every year we get a question either on zeroth order or first order. So this derivation you will prepare. Okay, next after this derivation is given, after this derivation is done. Okay, next we have what? Yeah. So we have the examples. Okay, so here is first example. So we have seen two examples for zeroth order. First example for first order, second order example is there. Like second example for first order reaction is there. Okay, so highlight these examples and then you can see this graph. Okay, these are also super important, students. Graphs are asked very important. So please make sure that you have practiced this graph at least. Okay. Now coming to the next part, if I just move forward here, another example is there for first order. Okay, so this is third example for first order reaction. So just write down first order in your notes and write down 3 examples. Okay, next what is there? You have to do these questions, that is there definitely. Then this is something which is asked in the recent years. Okay, derivation is there for the gaseous phase. Okay, in gaseous or in gaseous terms, or I can say in the terms of pressure. Okay, so this reaction you can write down, this derivation also you need to prepare. Okay, so this is also very important derivation here. Okay, clear? Now coming to the next part. Okay, so now the numerical is also important based on that particular expression. This numerical is very super important. Okay, now we will move towards the half-life. So half-life is the first one, is you should be knowing the definition, right? So definition is there, very important. Okay, please underline this line, definition is there. Then you have the derivation for zeroth order half-life and first order. So this one, this is there, and you have these 2 derivations. Okay, half-life derivations for zeroth order and first order reactions. This is important. So one second. Yeah, so this one is important here. Okay, so this is important. Okay, and the first previous one is also important. Next, after half-life, what all we have? Okay, so here you can see, for this is the conclusion. For a zeroth order reaction, T half is proportional to R naught. For a first order reaction, T half is independent of the R naught. Okay, this statement is important. Okay, next if we move forward here, yeah. Next you can just move forward. Yes, this table is again very important. Here everything is given, differential rate law, integrated rate law, graph, half-life, every one formula sheet is there. So please make sure that you revise this table properly. Okay, so this is also important table. Okay, fine. Now moving next, we have the second order, pseudo first order reaction. So what is pseudo first order reaction? This is the definition or an explanation. This is the first example of pseudo first order reaction. Okay, and then you have another example of pseudo first order reaction. This is this one. Okay, so 2 examples of pseudo first order reaction. And if some question is asked like why ethyl acetate and water reaction is a pseudo first order reaction, why, then this one will be the explanation. Okay, so if this is asked like why this is a pseudo first order reaction, then this will be the answer. Clear? I hope this is clear. You have to write the question. Suppose it is asked why the reaction between ethyl acetate and water is a pseudo first order reaction, then this is what you have to write in the answer. Clear? Fine. So now if we move forward, we will get about the temperature dependence. Okay, so here first is there what you mean by temperature dependence, how much rate constant increases. This can be asked as an MCQ question. Okay, next coming to Arrhenius equation, the terms in the Arrhenius equation. Okay, these all terms are explained, so that you should be knowing properly. Okay, next, what does Arrhenius think about a reaction? What is Arrhenius theory of reaction? This is there. Okay, so what I can say, this is Arrhenius theory. Just if any question is asked what is Arrhenius theory, okay, then this point you have to explain. Okay, Arrhenius theory here. Next, what is there? Here the definition of activated complex, activation energy. Okay, next we have something, yes, this is Boltzmann distribution curve. This curve is not important, but you should be just knowing like what are the terms in this Boltzmann distribution curve, that is important. What is most probable kinetic energy, the definition, that is important. Next we have this curve, this diagram is very important. Okay, so in Brahmastra also I have given you question from this one, so this explanation of this graph or this particular diagram is important. So what does it say, what happens when you increase the temperature, okay, why the curve shifts towards maxima. So these all things are explained here. Okay, next we have the conclusions here of this particular graph. When you increase the temperature, what happens to curve, how does it shift. Okay, and next we have that what does this particular, this is very important, what does e to the power of minus EA by RT symbolize. This is important. So you can just see here what all things, what does it represent, number of molecules having kinetic energy greater than EA. Okay, fine, then this is the equation, then you have plot, then we have, this is important, how can the rate of a reaction increase. So the rate of the reaction will increase with the increase of temperature or the decrease of activation energy. Okay, these are the two important factors, temperature should increase or activation energy should decrease. Okay, next we have here derivation of this one, this graph is important. Okay, this graph is important, then you can see two temperatures, this formula is super important. Okay, so numericals from this particular formula is obviously asked. Okay, so this is very important. Okay, next if I move forward, what we will get, okay, yeah, this is effect of catalyst, this is very important again. So what is a catalyst? First the definition of catalyst. Okay, next what does this intermediate complex theory tells you. Okay, so question may be asked what is intermediate complex theory. You might think that this is not there in the book, but yes, it is there. So what does this theory say? According to this theory, a catalyst participates in a chemical reaction by forming temporary bonds with the reactants, resulting in an intermediate complex. This has a transitory existence and decomposes to yield you products and the catalyst. So 2 points, you can easily get 2 marks, intermediate complex theory. Okay, so please highlight this one. Next, okay, so what does catalyst do? Catalyst provides an alternative pathway or mechanism by reducing the activation energy. Okay, now here there are certain things. This graph is also very important, it is asked many times in the exam. Okay, so this graph is very important, so please mark the levelings, read the graph properly and do all the levelings here. Okay, next after that we have something regarding the gives, what does the catalyst, sorry one second, yeah, what does the catalyst do and what does it doesn't do. Okay, so all these things are given here. So you can see a catalyst does not alter the Gibbs free energy, first point. It catalyzes the spontaneous reactions but not the non-spontaneous reactions, second point. Third is it is also does not change the equilibrium constant. Okay, next it helps to attain the equilibrium faster. So these are some properties of this catalyzed reaction, so please note down these points. Okay, next we'll come to collision theory. Okay, so we have understood Arrhenius theory, intermediate complex theory and collision theory. Okay, so collision theory, what are the postulates are there here? The reactant molecules are assumed to be hard spheres. These are the postulates of collision theory, so you have to note down these points. Okay, so these all are the postulates. What is ZAB? Okay, Next, what is effective collisions? This is super important. You should be knowing the definition of effective collisions. Next, the examples of effective collision is given. So suppose a question is asked like explain effective collision with an example, or explain the role of orientation in an effective collision. Okay, so write down this question, what I am saying, explain the role of or explain the importance of orientation in an effective collision with example. In that case, you have to give this particular example, how does proper orientation actually matters in a reaction. Okay. So next you can see the orientation factor, what is it, that P, what does it gives you, what does it tells you, and how does this equation stands. Okay. Next, so what are the, according to collision theory, what are the two factors which will give you the reaction? So that is your activation energy and proper orientation of the molecules together. Okay. Next, what is the limitation of collision theory? Limitation of collision theory or drawbacks is it assumes that all the chemicals reactants are hard spheres. It doesn't take account its actual structure. Okay, so that is the limitation. Okay, so now here something is given, what is threshold energy? Threshold energy is the activation energy plus the energy possessed by the reacting species. Okay, so yes students, that's all in this class. Okay, so I have discussed everything, so just highlight these points, write down the questions that I told you in like aside in the text part. Okay, and if you want me to solve the in-text questions and NCERT questions, so please put down a comment and let me see if it really help you, then we'll definitely do it. Okay, so that's all students in this class, and thank you. And if give me your feedback regarding this session that we have started, or what else extra could be done so that it will be more helpful to you, so that we can improve and can be like more beneficial for you. Okay, so please just express your thoughts in the comment section. I'm reading each and every comment. Due to some time I haven't replied to some of your comments. In the solutions video I have got very positive comment, and so I'm continuing in the same way, but please let me know individually your feedback, your essence about this particular series and about particular chemistry videos, how we are doing, is it going well or not, or if you want some modification. Okay, that's all students, thank you and see you soon in the next class.